Hi everyone, I'm Raghav, and in this video, I will just give the lead code, GFG contest, and I will be recording whatever I do. And you, like, whenever I will have to do something, instead of using a notebook, I will do all the calculations here on OneNote so that you can also see. And once I'm done with all the problems, then I will discuss the way I did them, and obviously, I will just upload the screencast right after the contest. Oh, they also have video editorial. Okay. Top rankers get up to this. Let's read it. We will code in C++. Time penalty is 5 minutes. So we will try not to have any penalties. Each question has hints so that maybe this is not looking good. We can use hints during contests, or maybe it's good. But people can like really easily exploit it. Maybe just create two accounts, use hints on one of the accounts, and give the contest from second ID. People can like really easily exploit this, so it's not very good. For plagiarism, I don't think they will have a very good plagiarism check. And the segment goes live after the contestants. It can be used to interact with other people. I don't know. Okay, so I'm not sure if I can get a good rank. I would try that at the very least I get among the top 50. Um, like rank 1 to 3 is not really doable for me if some other high rated coders also give. And in case if no other good coder gives the contest, then even a newbie like me might get a good rank. Click here to know about the series. Okay. Mm. Oh, DFP. Wow. I'm not able to write here properly, so I might have a bad handwriting during contest. What happened? Valid triangle, you are being given three sticks ABC, whether it is possible to get. Um, Return. It takes so long to see. Some minus mx isn't working. Oh, we have to return a string. Wow, I didn't notice. To be honest, I didn't even read the problem completely. So we have to return yes or no. I hope it's yes or no. Yep. Okay, it's coming out. Let's see if it works. I wasted time without reading the problem. Briefly. I could have saved some time. Yeah, given how many separate palindromes, both inclusive, has the number of palindromes. Right, if it is, count the number of super palindrome numbers in the range L2 are both inclusive. If it is a palindrome and decimal representation, and it is a perfect square as well. Okay, so a number should be perfect square and it should be uh, a palindrome. So all the numbers from 1 to 9, and then 49, 1 to 1. I'm having a feeling that it would be only, oh, sorry, 484 and 440. Me. Okay. What about 111 cube? 111 into. No. So we have to check this again. I think it will come here. Okay, I think I have just messed up at this problem. I will look at it later on. Notation, you can replace AB with BBA, then remove operation so that most AB is left. Okay. I want to remove AB and I have BBA. Okay, so wherever I find, I will have to do the operation this many times. And if there was an A here, yes, yeah. So if A is coming up like this, you will have to apply this many times as well, no? BBA, and then you will have some. Then you will have this, and this is the new problem. Okay. Maybe I can just solve from left to right. Wherever I see an AB, I will just look towards the left. How many times? If there was a B here, it would not really matter, no? Okay, so how many times A came? Um, that's too many. That's literally too many. I was expecting a really easy contest, to be honest. Okay, so okay. So this AB came to this position. Um, hmm. This is like let me write on this. This AB came to this position. So if there were AAB triple B, you will choose this. You will make it equal to BBA, BB, and you will have AA here. Then we will deal with this. You will have A, B, B, A, and B, A, B, B. When you will deal with this, you will have B, B, A, B, A, and B, A, B, B. So now you're having this as a mess. Now, we will deal with it. So we'll have B, B, A, B, B, A, and A, and then B, and then A, B, B. I think I'm missing out something maybe. You can replace an AB with a BBA and you have to figure out the minimum number of steps so that no substring AB exists. So wherever you have an AB, you can just convert it to BBA. It definitely gets rid of the AB here, but if there is a B on the right hand side, then this pair is formed, and if there is an A on this left hand side, then another AB pair forms. And this is inserting a new B, and okay, so what it does is it just inserts a B in the middle, and it is swapping A and B on the left and right side. Okay, so how will it solve the problem? If you're having multiple for this BA, it will become B. Sorry, for this AB, it will become BBB. Let's forget about the BB thing for now. We will have A, BBA, and whatever the suffix was, and then we will have to deal with it. So we'll get BBA, and then BAABB. Um, you had three Bs earlier. So these will not, never cause any trouble for you now. You can just safely ignore them. The thing is, you're having this ABA, ABB. Again, you are having this pair. You will make BBA, and you will have again these two are also never gonna cause you any trouble now. You are having AA and this A, and then BB. So out of all of these operations, you just got rid of one B. It took us okay. This is not looking very good. Let me check it once again. We had three A's, three B's. Maybe let's forget about all the other B's. If you are having something like AAB, it will take one operation to make it ABBA. Then it will take one operation to make it. Uh, let's let's get rid of this B. Forget about this B. ABA, and it will get one operation to make it AA. Okay. So just for removing one of the B's, first of all you have to make one operation here. Then uh, one position, then two positions. No, it may take more. If it was having AAB, it will take one operation to make it AABBA, then another operation to make it ABBABA, then another operation to make it ABABA. Like B is on the left hand side does not make anything. Then AABA. So now this AB, ABBAA. Now this one AVAA. Now this one AAA. So when there were two A's, it took me like three operations to remove a B. And if there were more occurrences of B on the right hand side, it would be fine. Okay. And when I'm having three A's coming together, one, two, three, four, five, six, seven. It took me seven operations. I don't see anything here. A A A A B. Apply here. A A A B A. Sorry, B B A. Actually, having multiple V's or one B does not really matter much, I think. No, it does matter. It does matter. Okay, so I think I should think in a different way. What if there are multiple B's? Your A will go towards the right hand side. Then your A will again go towards the right hand side. B, B, A, B. Then your A will again go towards the right hand side. Okay, so I was just thinking in the wrong direction earlier. What happens is whenever you are having something like this, for the rightmost A, it will go to the rightmost position, and whatever the number of B's there are, they will just get double. So there was one B, now there are two B's. Now talking about this A, it has to deal with three B's. Then talking about let for this B does not really matter. Talking about this 1 plus 3. Then talking about this A, he will have to deal with 6 and then these two, any 8 B's. There will be 12 in this case. Okay. So if I just look at one of the examples here, for the first guy there is 1B, and then for the second there are 3. Okay. Talking about these 1 plus 2 plus 4, this is 7. Okay, I think I've got the solution. I should have noticed it earlier probably. Int n is equal to s dot length. Maybe say it as long answer. If si equal to b, then cnt plus plus, you can just have a variable cnt to 0, or maybe just create cnt like this. If else answer plus equal to cnt, and this should work probably. Wherever I see an A, I just have to do this. Okay, it worked. I took quite long at it, at the B problem, C problem. I was expecting it to be very simple. Like the last time I gave the contest, the problems were super simple. Uh, you are having two integers L and R. You have to count how many super palindromes exist in this. So, like the intuition is pretty simple here. From L to R, I know that um, since these have to be the perfect squares, um, I have to figure out the number of elements in the range from square root L to square root R, whose square is equal to, like, whose square is a super palindrome. So I can just say int is palindrome. Uh, I have a doubt. Will I consider 100 as a palindrome? No. Okay, great. Um, int answer is equal to 0 for I equal to until I is less than until I is less than equal to R. Um, if I into I is less than L, then just continue. After that, if basically just answer plus equal to, okay, this is the brute force for solving this problem. I thought that since it's a GFG contest, I was expecting something to be like very simple. Okay, let me put up the laptop on charge. Okay, looks like I have really messed up. I have taken 18 minutes to solve these three problems. I will get a bad rank today. You're having two positive, an array and two positive integers and n k. Okay, and question is like any element from the array and decrease it by p and any decreases by p. Okay, choose any element from the array and decrease it by p, and the remaining elements will be decreased by q. If any element becomes negative, you can replace it by 0. You have to return the minimum. ठीक है. Okay. So it depends upon whether p is smaller or greater than q. Um, if p is greater, okay, so in case if p is greater than q, then the problem can be solved very easily with a binary search. Do you have a constraint on p and q? Okay, p is always greater. Great. It's then like really simple. Um, the minimum number of operations I might require is 0. Max is equal to like 25 maybe. And the result will definitely be equal to e. If check of n, then result is equal to, uh, we will check for m. So the idea is long wait. If see, otherwise I will just identify. Okay, so it unfortunately it might get some errors right now. Um, okay, we don't really need to create this. It's not working. Okay, so what's the problem? for something like 1, 2, 3. And when you talk about 0, you are having how many extra points do you need? Um, AI minus Q into M. Okay, so like Q into M is the amount everybody would be deducted, and um, apart from it, you need this many extra points for which you will need like this many extra things to be like you will require this much, and it is coming up to be 0. See out and running the deck. Okay, it's always giving me 0. Oh, sorry. Ah, I had to write this. I thought that I have used the less than equal to operator. So that was the main issue. It's coming up to be 2. Okay, let me just check it once again. Requirement, it can go long. It's fine, otherwise I need this much. Take it. Result time is equal to minus 1 and 3. Okay, it got solved. Looks like the problem is fine. I believe that they should have mentioned that P would always be greater than Q at this place, not at the bottom only. Like at the bottom, obviously it should be mentioned there as well, but they should have mentioned it at the front also, that P would always be greater than Q, because it was very important for solving this problem. Uh, I hope I did not get any wrong answers, so the rank might not be that bad then. Rangi Raghav is at the top with 100 score in 8 minutes. Wow, he solved all of them in 8 minutes. That's like quite amazing. Am I there in the leaderboard even at the bottom? At any place? Looks like I can't see myself right now. The leaderboard will take time to be updated. Let me tell you about all my approaches for all the 4 problems. So for the first problem, it is a standard thing. Like I studied about this in school, that if there is a triangle, which like if there is a triangle and it is having 3 sides as ABC. For now, let's say that A is less than equal to B is less than equal to C. Um, in that case, C should always be less than A plus B, and it does make sense. Let's say if one of the sides is greater than the sum of the other two, then like the point should, like this case will happen when A plus B is equal to C. It will not have any positive area. And for all the other cases, it's not even possible to connect 3 points, such that two of the points are at very huge distance and the third point is not having like, enough distance with any of them. So this is just some basic maths. And the way I wrote it is, I said that sum is equal to A plus B plus C and mx is equal to the maximum of all of these three. The reason is that these ABC might not be in sorted order. Actually, they might be. No, the ABC are not in the sorted order. So one thing you can do is either just store them inside some array and sort it, or maybe just apply swap operations, but for that you will have to write longer code now. To write a shorter code, you would just tend to have the max and the sum. And if you look at it, this equation is nothing but the maximum element should be less than the sum minus mx. है ना? So I just wrote this thing. Mx should be less than sum minus mx, and initially it did not work out because I had to give up the string as the output, like yes or no, and was just returning the bool. Actually, I had not read the problem. Like I just read the problem till here. I did not even read this. I think for now we can write it a little better, like this. Let's see the second problem. Second is just complete brute force. In the second problem, I had to tell how many super palindromes exist in the range from L to R. For super palindrome, there were two conditions. One of the conditions is it should be a perfect square, and the second condition is that it should be a palindrome. Obviously, the name is suggesting it. So, as it says that we should have a perfect square, the idea which I got in mind was I can just have a for loop from the square root of L till square root of R, and like I can run a for loop here instead of running up a for loop between all the elements from L to R, because like we can't really iterate over all the elements from L to R, since in the worst case L might be equal to 1 and R might be equal to 1e9. But from square root L to square root R is possible because square root R, like in the worst case, would be around 3e4, that is 3 into 10 raised to the power 4, around this. So I can go on to each and every element. Yeah, I can go on for each and every element uh, in this range, and I know that I will just talk about I into I. So basically all the perfect squares would be counted when I was like, let's say if L is equal to 100 and R is equal to 1000. If I was normally iterating over the range from L to R, then I would have been considering 100, 101, 102, and so on. And most of them are not even perfect squares, so I'm just wasting out my computation here. But when I iterate over the square root of 10, 100, which is 10, square root of 30, 1000, which is 32, or I think 33. No, yeah, 31. Not even 32. 32 is also greater than 1000. When I am iterating over this range, I will only check for the perfect squares, which are these elements. So the reason I wasted my time initially was, like since it is a GFG contest, I was expecting that the problem might be even simpler than the brute force. I thought that it might have something to do with just counting of elements like 149 and 121, 12321, and 484. So I thought that it might be something like that, but it seemed to be a brute force. Actually, brute force is more beginner friendly. The chances of making mistake in brute forces are really less. And for checking whether a given number is a palindrome or not, first of all, I'm just converting the number into a string, and then I'm reversing the string. If the string after reversal also stays equal, then it is a palindrome, else it is not. So in the case of 144, the reversal will be equal to 441, and here in this case the reversal is not equal, so it's not a palindrome. So I just checked out for all the elements here, and yeah, it could have started with square root of L directly, but square root of L might have some precision errors, so you will have to maybe start with something like this to be on the safer side. And I thought that in the worst case, I would, like in the worst case when L is equal to 1, I will anyways have to run a for loop this long. So why don't I just write it like this, just to avoid complications. Yeah, by the way, the time complexity here will be equal to square root of R into the time taken for every string to check whether it is a palindrome or not. Since the size of any string would never exceed 1e, like not even 1e9. Like it will have at most 9 characters now in every string. So we can just consider it to be some constant time complexity, or maybe say it as big of 10. It should easily pass. Um, for the third problem, string replacement. In the string replacement problem, I really wasted a lot of time for no reason. Like I should have got it a lot sooner. So the idea was, in the third problem, that is this string replacement, we would be given some string and we want to eliminate all the AB characters. So from this AB, I can convert it to BA, and that's it. That's what I can do. Just pick up any AB and make it equal to BBA. And my aim is to get rid of AB from the whole substring. So in case if the substring was having A on the left and B on the right, then just applying the operation will not really remove all the occurrences of AB in the substring. Indeed, it can actually increase the number of occurrences of AB. The mistake I made was, like, just on reading the problem, I tried to think of a simple test case, maybe something like AABB. I think that this was the test case I generated for me, and I tried to see what will happen when I apply the operation here. So it got these two. Then I started solving for these two, and then you're having this pair and so on. So there were a lot of pairs. And one more thing which I knew was I had to return the answer modulo 10 raised to the power 9 plus 7. So obviously there can be a lot of like the in a small string there can be too many uh, operations required. And just on like solving this part, I really felt that the number of AB substrings are actually increasing. So it was not really uh, simple to find out the number of operations I would require when I was like solving it manually. Then I noticed that if there are any b's at the beginning of the string, they have no significance. I can just ignore these b's and I can focus on saying that if I have AB coming up at the first place in the given array, in the given string, then I can consider it as BBA, and the first two characters have no significance because like the first two characters can never be like if the first characters of the string are b's, then they can never be a part of a string AB because they are not having any A on the left of them. So I can just consider as if I never had those b's in the string. And like you can just see the way I was approaching the problem here. And then I suddenly noticed that converting an A B into BBA, like instead of saying that my B is moving towards the left and I want to find out the number of operations to make the string in a way that all the B's are on the left and all the A's are on the right, I can just consider it as my string AB is becoming, like obviously the string will become BBA, and I can consider that the number of B's have doubled and A has gone towards the right. And just as soon as I got this idea, the problem was like really simple, because if I have any string like A B B B B, for getting this A towards the complete right, similar to the point of getting B's to the complete left, because if a B is coming at the first position, it cannot be a part of the AB substring. Similarly, if A is coming at the rightmost position, it cannot be a part of AB substring. So either I can think of moving B towards the left or moving A towards the right. So here I just thought that, hey, I can move this A towards the right. I will have to apply, like, first I will have to apply the operation here. I will have first few A's, then I would have formed BBA, and then I will be having these three B's. Then I will apply an operation here. So again, the left hand side is completely untouched. This right hand side will also remain untouched, and these AB will become BBA. Then I will apply an operation here, and like A will come up towards the right, then I will again apply an operation here, and A will come towards the complete right, and I can just ignore it now. So the thing which is happening here is all the B's towards the right hand side of this A will become like their frequency will become double. So I can just say that when I will make sure that this A gets towards the complete right hand side, all these B's would have also doubled, and my string would have become A coming three times, then BB, 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 BB. Basically, B is now coming up 8 times, and then I'm having A coming up at the end. Similarly, I will just do the process for this, this, and this. So now it is like very simple to do. For solving this kind of a problem, the approach I had in mind now is go from right to left, keep track of the number of B's, like because whenever you want to get rid of an A towards the complete right, you will need to know about the number of times B is coming towards the right. So why not just iterate from left to from right to left, keep the track of the number of times you have got B. Maybe let's say it as count B, which is initially 0, and like when you would have iterated till this point, it would have got 4. Then you got this A. We know that you would require count B number of operations to move this A towards the right. So my answer will become like will be incremented by count B, and the frequency of all of these B's would have doubled. So count B will become like twice of it, or you can just add count B here as per your choice. Both of these are the same things, and that's it. That's all you have to do. And this answer and this count variable can become like really huge. So to avoid it, like the problem, since the value can become very huge, which would be out of the range of a long, the problem said that you will have to answer like you will have to return answer modulo mod. So you just have to keep uh, like you just have to take care of the overflows. So for keeping care of the overflows, what you can do is instead of saying answer plus equal to count b, you can say answer is equal to answer plus count b by mod. And similarly for count b equal to um, count b plus count b mod, and that's it. Okay, so that's all we had to do. I wrote it in a different way, like both of these are the same things. It is also equivalent. Okay, now let's talk about the fourth problem. In case of fourth problem, I almost instantly got the solution for the case when p is greater than q. And unfortunately, they did not really mention what if like will p always would be always greater than q or not. Uh, the good part is that I scrolled down and saw this here. Or maybe I'm not able to read it. I don't think they have mentioned it here. Yeah, they have not mentioned it here. So, like, you already know what the problem says. The problem says that you have been given an array. In one operation, you can just choose any index I. That element on the index I will be reduced by p, and all the other elements in the array will be reduced by value q. So, for all aj, where j is not equal to I, um, and we know that p is greater than q. So, I just treated this problem as saying that in one operation, like I just treated this as saying that in one operation, all the values in the array will be reduced by q, and then I'm having a variable pq with the name pq, which is equal to p minus q. The index which you chose will be reduced by pq even after being reduced by q. So basically, the total uh, subtraction from this variable would be equal to p only. I've just written it in a little different way because now it is looking easier. I just got this intuition, and Now the thing is, if you can make all the elements equal to 0 in k operations, you can do it in k plus 1 operations also, k plus 2 operations also, and so on. And if you cannot do something in, let's say, if it was k2, let's say if you cannot do some operation, cannot make the element equal to 0 in k1 operations, then you cannot make it equal to 0 in k1 minus 1 operations either. You cannot make it equal to 0 in k1 minus 2 operations either. So basically, here you can see, uh, like it does make sense now. If you can, just if you want to prove it as well, that why is it always true, just imagine that if you can make the elements of the array equal to 0 in k operations, then on the next time you can just apply an operation on any index, since all the values are already equal to 0. Yeah, I did not mention it earlier, but when you reduce these values, if a value becomes negative, if for any age it becomes negative, you will just consider it as 0. They cannot go negative. Okay? So here, if you can make all the elements equal to 0 in k operations, you can just apply the next operation on any of the indices. The values, even after the operation, will just remain zeros. So it would be possible that after, like on the next operation, you are able to make all the elements equal to 0. So that is why, if you can make all the elements equal to 0 in k2 operations, then you can do it in k2 plus 1, and similarly k2 plus 2, and so on. And when I say that if you cannot make all the elements equal to 0 in k1 operations, if you cannot do this thing, then how does it prove that you cannot do it in k1 minus 1 operations? We can solve it, like we can prove it by contradiction. Let's just imagine that if you could make all of the elements equal to 0 in k1 minus 1 operations, then it means that you should be able to just apply an operation at any place, and you should be able to make all the elements equal to 0 in k1 operations. But we already know that it is not possible. Like we have we already know that we have made the assumption that it is not possible to make all the elements equal to k1 equal to 0 in k1 operations. So yeah, we can say that it would not be possible to make all the elements equal to 0 in k1 minus 1 operations. है ना? So for any k less than k1, it would be not possible, and for any k actually less than equal to k1, and for any k greater than equal to k2, it would be possible. This already gives us a very solid hint of binary search. Now, how will you check if it is possible to make all the elements equal to 0 in k operations? Um, the thing is, if you apply k operations, this thing would definitely be applied on all the elements now. Like this thing is gonna be applied on all the elements. So all the elements will be reduced by k into q, right? So for all the elements which are less than equal to k into q, you know that they will just become equal to 0. You will never have to choose any of those elements, when like in every query you choose one element now, so you will never have to choose that as one of the elements, because they are always just gonna become equal to 0 anyways. And if there is some element which is greater than k into q, then you will have to apply some operations on that element so that it becomes equal to 0. In one operation you can reduce its value by pq amount. So if you have a value, let's say aj, like if you know that aj minus q into k is equal to maybe 12, and in one operation, like let's say p is equal to 5, so you know that you will have to apply 12 by 5 seal number of operations when you choose this element, so that it would be reduced by 5 three times. And now this comes up to be 3, so that the value becomes equal to 0. So like seal division, if you ever have to say a by b seal division, it is always equal to a plus b minus 1 by b, where you're having float division by default, which we have in C++. So I can just say that I will require aj minus q into k plus pq minus 1 divided by pq number of operations. In my code, I have called this thing as, with a variable left, the value which would be left after the uh, k operations. So in my code you would see left minus pq plus 1 by pq to be written. Obviously you don't really need to create the variable with name left. So whatever is this value coming up to be, you can just uh, find out the sum of this value for all the variables. I just kept track of it into a variable with name rec, which is nothing but the short form of required, the number of operations I require. So I created a variable rec for it. And I know that since I will be applying k operations, I will be able to choose at most k elements. So this value of rec, which I got overall, uh, this thing should be less than equal to k. That's it. So in my binary search here, in my binary search, I'm having the starting range from 0, ending range till 1e5 because the largest element will be less than equal to 1e5. So obviously I will never require more than 1e5 operations in any case. And this is nothing but a simple binary search template, like not a template but an invariant, which would always be the same for all the problems. Initially I initialized the answer with variable e, and it will just get reduced every time whenever I get true from the predicate function. The predicate function, uh, like instead of having this k which we were discussing while talking about the logic, in my implementation I named it as m, which was just for like the word with which I had declared the variable, sorry, the name with which I had declared the variable. So I'm going on to each and every element. If the value is already smaller than q into m, by the way, q into m might be very huge. The value of q may be as large as 1e5 minus 1, and the value of m can also be like very huge, maybe 1e5 by 2 in the first case. So the value of q into m may be very huge. Can we actually have it smaller? No, we will just have to, like, it's already good enough. I was just thinking if we can make this condition to be more strict, but it's fine. So if it is already smaller, obviously you don't need to do anything. If it is greater, then I just calculated the remaining value that will be left at this variable. So that many times I will have to apply the operation on it. And this is the seal division of left by PQ. And the answer should be less than equal to none. So that's it for this contest. We have discussed all the 4 problems. Now let me see if the leaderboard has been updated. Okay, I got the rank 5. Um, how slow was I? If I had been like 30 seconds faster, then I could have got rank 3. By the way, this is a really big domination. A person is able to solve all the 4 problems in 8 minutes, and the second guy is solving it in 21 minutes. Uh, I don't see any more similar. Okay. Okay, very well. So thank you for watching the video. And in case if it helped you even a little bit, then please mention this in the comment section. I would be really happy to see your comments. And bye bye.